Hi guys, welcome to tonight's Facebook Live training from Drayton. Thanks for joining me. Tonight we're going to be looking at wiring up 𝗲𝘀𝗀𝗃, and we're going to be looking at how you do it when it's not a straightforward installation. You know, we always talk about industry standard backplate and how easy it is to take off an LP and pop on the appropriate channel version of the 𝗲𝘀𝗀𝗃 hub. But we're going to be looking tonight at what you need to do if that's not the case. So the sort of scenarios you get if the boiler's got onboard controls, or indeed no controls at all. It may be that your customer is controlling their boiler just by switching it on and off, you know, when they want heat. So if you can get 𝗲𝘀𝗀𝗃, or at least if you can get external controls, there's something that will manage time and temperature, you'll make about a 50% saving. And then if you optimize that with 𝗲𝘀𝗀𝗃, there really are some good savings to be had if you can get some controls onto your customer's boiler. So that's the thing we're going to be looking at. Any questions as we go along, just pop them in the comments, and I'll keep up with them as we go along. So I think we'll just get into it. Let me drop the top-down camera on. So the first thing I really want to talk about is we'll start with the combi boiler. So here we would be looking at a 𝗲𝘀𝗀𝗃 kit one, which would have this. So what you're looking to fit is this, which is the single channel version of the 𝗲𝘀𝗀𝗃 hub. So here we've got a mock-up of a boiler, and this happens to have one of our clip-in controls in it, which is the 𝗵𝗲_RF. But the issue you've got here is the boiler's already got controlled, because this will be linked wirelessly to one of our digistats. So you've already got time and temperature control, but it's being done on board within the boiler. So there's no way of being able to just take a control off of the backplate and get the 𝗲𝘀𝗀𝗃 hub installed. So what we need to do is we need to decommission the onboard controls, and then we need to run a wire out the back of the boiler. So the way we do this, and this obviously happens to be a Worcester boiler, which has got our clip-in in it, but this is the same principle for all boilers that will accept third-party controls, and not necessarily just for 𝗲𝘀𝗀𝗃 either, because once you've got the wire out the back of this and it's screwed to a backplate on the wall, it's up to you what you actually fit to it. So first job is to decommission the old control. Now, obviously, make sure it's isolated. This one's not even plugged in. There's not even a plug on the end of it. But you remove this cover. There should be a cover here, but obviously on this one it's missing. But there's a single screw, which this cover pops off, and then you can just grab hold of the clip-in, pop it upwards, and you can take it out. And you can see it sits on a ribbon cable. Now the ribbon cable plugs in to the, and then you've got the thing disconnected. Now, obviously, if you're diligent and you keep the blanks that come, because obviously when this boiler was first installed, it would have had a blanking plate in here. That's been replaced by the clip-in control. If you've still got the blanks, you can pop the blank back in there, but most of the time you won't. So then, in order to make sure that we've got nothing exposed here, you need to put the old control back in. Obviously, it's not going to be up, so you would just bury the ribbon cable there and pop that back in, as long as the ribbon cable is not connected. But we do need to have that in there so that it protects the we've not got any PCB or anything exposed in the front of the boiler. So that's that decommissioned. We would then off with the cover, and if we have a look around the back here, this is what we've got. So we need to get in, and what we essentially need to do is, as well as having the mains in cable here, which is this one here, we need to get this cable here installed, which is a 5-core cable that is going to go out to the backplate of our 𝗲𝘀𝗀𝗃 hub. So undo the screws, and you can take the cover off. These just slide off. And like I say, every boiler is different, or all your different manufacturers will be different, but the principle here holds, which is that we need to get that 5-core cable installed so that we can get it wired to our backplate, so that we can get a 𝗲𝘀𝗀𝗃 hub on there. So this is typically what you will see inside. So this wire here that we've got is our mains in. So that's providing an earth to the chassis down in there, and it's also providing a live to our live terminal and a neutral to our neutral terminal. Now, these two terminals here, which are designated as LS and LR, those will have a loop of wire across them. So when they leave the factory, they will have a loop of wire that links those two terminals together. So what that means is that if you would just power up the boiler with that link across those two terminals, the boiler is going to fire straight away. So what we're going to do is we're going to bring a 5-core cable in. The colors of our 5-core, we've got our brown, we've got a blue, and we've got our earth. So that mimics the mains in. So your earth will go to the chassis down there. Your live will piggyback onto the live in there. You can see there's 2 wires going in to the live there. And then we've got a separate terminal for our neutral on the NS. And then we've got our two wires here. These are our switch lives. And you can see there that they're indicated with a little brown flag. That's to tell us that they are live. They will go live at some point. So typically, LS is your supply, so that's your live supply. So the black wire there that's going out to the back plate is a permanent live supply. It then goes through the switch in the WiSER hub. So when the relay makes, what the voltage that's going out on the black will come back onto the grey, onto LR, and that will then be the signal to fire the boiler. So just to recap, we've got our mains in. That's our 3-core mains in. That's going to be coming from hopefully a 3-amp fuse. And then the bit that we're adding in, because we want to make this have external control capability, is our 5-core cable here. So we've got our live, we've got our neutral, we've got our earth, and then we've got the black and the grey. And it doesn't actually matter which way around these go, but typically your black will be your permanent supply and your grey will be your switch live. But either way, we need to flag them as being live by having the little brown flags on there. So if we have a look at the other end, this is what we've got on the other end. That's the boiler end done. So this is the bit that you're going to be screwing to the wall. So here we can see it's important that you don't get those the wrong way around. A lot of people expect it to be live and then neutral, but it's not. It's actually neutral and live. So that's the brown and blue that you saw at the other end in the boiler. And then we've got our earth. Don't actually need to earth this. It's a class 2 product, but it's a 5-core cable. You've got an earth core there, so you may as well stick it into the earth post rather than just trimming it back. And then once again, we've got our brown and our grey and our black, which have got the little brown flags on to indicate that they're switch lives. The black going to terminal number 1, that's our switch live, and the grey going back, that's our switch live back to the boiler. So supply in, switch live out. Now, if you happen to stick it, instead of putting it onto 3, onto terminal 2, that's going to work in reverse. So your boiler will fire when there's no call for heat, and it will stop when there is a call for heat. Obviously, we don't want that. We want the boiler to fire when there is a call for heat. So terminal 3 will go live, or essentially terminal 3 is connected to terminal 1, which is a live supply when there is demand at the boiler. Terminal 4 on the single channel hub doesn't get used, and if you need to refresh your memory, you can see etched in to the back of all of the hubs. This happens to be the single channel, but you can see there the little wiring diagram just lasered in to the casing there. Neutral live, terminal 1 is your common. Now these are volt free, so if we saw on the boiler we had those terminals LS and LR. Now on a Worcester boiler, those are known to be mains. LS is a mains supply, and LR is expecting to see that mains come back to it. But if it was a 24-volt boiler, you can see that you could bring 24 volts onto number 1, and then you're going to get 24 volts back on number 3, even though your neutral and live, your first 2 terminals, will be at mains potential to actually run the control. So like I say, once you've got this backplate on the wall, you can fit a WiSER single channel hub, or if you wanted, you could fit a digistat. So instead of having this backplate, you could use those 5 wires, and you could wire them in to the terminals in the new digistat, or have the new digistat receiver. So the important thing is always getting this 5-core cable out from the boiler, and a lot of the times you'll find that in order to remove the boiler casing, you need to be gas safe registered. So if you're an electrician, you just need to check that by removing the casing of the boiler to get access to that panel to do the wiring, that you're not breaking any of the seals from which we would need to be gas safe registered to do. So that's just something to be aware of. Don't just whiz in there and take off the covers. Some boilers will allow you to do it, but most of the time you need to be gas safe registered to remove the covers from the boiler. So once that's on the wall and screwed where you want, Wijzer hub clips on, 2 screws underneath, and then the remainder of the installation for Wijzer is done on the app. So then we'll move on and have a look at a 2-channel system. So you may have a 2-channel system with something like that, an LP. So this is your timer. Remember, to be Part L compliant, we need to have both time and temperature control. So if you've got an LP like that, you should have then a cylinder stat on your hot water, and you should have a room stat on your to do your central heating. Now we know that if we swap that out with the 2-channel version of the Wijzer hub, so that would be the direct replacement for that, we know that they sit on the same backplate. That's all well and good, but only if you have got a fully pumped system. So that means that you will have some zone valves. So your system, you'll need to have either 2 2-ports like that, making it an S-plan system, or a 3-port mid-position valve, making it a Y-plan system. Now, if you haven't got that, it's highly likely that you will have a gravity system. And that's not to be confused with gravity-fed hot water, where you've got a header tank in the loft, because you can have fully pumped systems with gravity-fed hot water. It means that you have your hot water's the pressure of your hot water is essentially fed by gravity, as opposed to having a pressurized system where you would have, say, maybe a MegaFlow cylinder. So you don't confuse what would be designated as a gravity system with gravity hot water. A gravity system is something where you don't really have independent control of heating and hot water in the same way that you do with like an S or Y plan. So if we take an S plan system, you open the central heating valve by calling for heat with your time and temperature devices, and that will permit flow only into, say, the central heating loop, and it will isolate the other one will keep the cylinder isolated. Or conversely, you can heat just your cylinder and not have your central heating on, so you've got independent control of both channels. With a gravity system, you don't have that. Now, the way to tell is if you've got a controller on your system like that, if you take it off its backplate, now you can see here on these LPs there is a little jumper just in there, and you can see just etched into the plastic it says P and G. Now this one happens to be in the pumped position, which is how they're set up when they leave the factory. But if you've got a gravity system, that jumper will be sat like that. Now what that actually does, if I show you this next demo, is when you've got the system, when you've got an LP set up in gravity mode, you can call for hot water on its own. So you can see there, I've just turned the hot water to the on position. But if I try and call for just central heating on its own, it automatically fires the hot water. And it needs to do that because we've got no zone valve. So the way that this is wired is the hot water side is wired directly to the boiler to fire the boiler up. And the central heating side is wired just to the circulation pump. Now, if you didn't have this condition, whereby when you call for heating, you get hot water at the same time, you would just be running your circulation pump and circulating cold water. So the gravity bit comes from the sort of convection of when you call for just hot water on its own. There is no pump in play here. This is just the convection current that, as the hot water leaves the boiler, it will migrate its way through the direct or indirect coil in your hot water cylinder. So this is obviously not a Part L compliant setup. This is not something that you would be fitting, but this gives you massive scope to be able to upgrade your customer. But you can't just take this off as you would an LP that was set up in pumped mode, because Wijzer needs to be fitted to a fully pumped system. So your options there are you need to get some motorized valves installed on the system, as well as a cylinder stat if there's not one already. Now, a lot of the time they will have a cylinder stat, but it's not always. But If you want to really drive your efficiency on a gravity system, you either need to get a mid-position valve in. Now, this is fine if you're only ever going to have the two zones, if you're only ever going to have water, one cylinder and one central heating, because one of the ports always remains open. So you can't have a mid-position valve and then start adding more two ports to it, if you wanted underfloor heating, because if you call for underfloor heating with your two port, whichever position the valve here was left in, it will also heat either the cylinder or hot water. So these are good if you haven't got a lot of space or you want to keep the pipe work to a minimum. You can fit a mid-position valve, but my preference is always to go for an S-plan system where you're using two-port valves, because these are infinitely more expandable. So long as you've got time and temperature controls for each one of these, you can start with saying just have heating and hot water. Then if you wanted to say split your central heating into upstairs and downstairs, you would just add another zone valve. If you then decided you wanted to have a circuit of wet underfloor heating, you would add in another zone valve. So if you're going to go to the effort of upgrading a gravity system so that it can be worked with WiSA, it needs to be a fully pumped system, and that is designated by having zone valves. My preference would be to turn the system into an S-plan system where you're using two or more zone valves in order to manage the flow on the system and also fire the boiler. Because remember, these have got 5 wires on the end of them, so the brown wire drives the valve open when you've tethered it to neutral, and then you've got your orange and grey. These are switch wires, and the orange goes off to fire the boiler. So as well as driving and permitting flow into the respective circuit, it also sends the signal to fire the boiler. And if you need some help on the motorized valve wiring and fault finding, have a look on our YouTube channel, because I've recently done some content on that. So there's some help on there if you need it. So that's how you would deal with a 2-channel system. There aren't really any more 2-channel systems out there that WiSA wouldn't be compatible with, as long as it's got motorized valves. Remember, if you do fit a 2-channel, you will use your existing cylinder stat, so we don't make any changes to the water side. It still uses your existing cylinder stat. But your room stat, if you've got a wired room stat, something like an RTS1, you would need to link that out. So not just disconnect it, you need to actually link the switch wires together. Now, that could be done on the back plate of the thermostat. Most people, though, will want the old thermostat to be removed from the wall. But if you don't want to do that, you can just go in there and identify the 2 switch wires and either put a link across them or merge them both into one terminal. But the more elegant way of doing it is to identify where in the wiring center the 2 switch wires for the room stat connect, disconnect them, and then just put a little link of wire across there, and that will link them out. That will essentially prevent any sort of air gap between the relay in the 2-channel hub for the central heating and the zone valve. So this is now going to directly drive your central heating zone valve. Right, let me have a quick look and see if there are any questions coming in. And there's one here about what would I do if I had a 2-channel system with plus hot water with WiSA, but using individual room thermostats. So let me see if I can sort of mock that up. So this is something I've seen quite a lot of the time when I'm fitting WiSA 3 channels. Is you'll get normally this is if it's a bigger property over 150 square meters, because again Part L requires you to have to do subzoning if it's over 150 square meters. But what you typically have, rather than having one centralized controller, because not many manufacturers make a 3-channel, and indeed we don't, other than the 3-channel WiSA, we don't have a 3-channel offer like an LP or something. So what you tend to find is that your installers will not have the timing bit centralized to a central unit like you would need for a 3-channel WiSA hub. What you're likely to have is programmable room stat. So it may be that you have a programmable room stat upstairs, you'll have a programmable room stat downstairs. And remember, because these are programmable, they do both time and temperature. So that ticks the box for the Part L compliance. And then for your hot water, you'll have something like a single channel timer. So you can, and geographically within the house, these are all over the place because these are, the thermostats are going to be in their respective airspaces, and it's likely that your timer for your hot water will be somewhere near your cylinder. Now, if that's the case, we essentially need to merge that into one unit where we can get, or we can fit, the 𝗲𝘀𝗀𝗀𝗀 3-channel hub. So you are going to need to do some wiring in the wiring center here, and actually there is going to be a video that's coming up on YouTube about this in quite a lot of detail, because like I say, every time I tend to do a 3-channel 𝗲𝘀𝗀𝗀𝗀 upgrade, it tends to be that it's not centralized into one unit. But to just give you the sort of briefing on it, in the wiring center, so you're going to have a wiring center because you're going to have hopefully an airing cupboard where your at least 3 motorized valves are going to wire back into the wiring center, and then from that wiring center you'll have wires going off to the respective thermostats for upstairs, downstairs, and the timer and cylinder stat for the hot water. So again, it's a 5-core cable. Now the cable I'm using is 0.75 millimeter 5-core, so that gives you enough cores to do what you need. And then in terms of the wiring on the back plate, you've got your neutral and live, so you'll actually have two separate flexes feeding the back plate. You'll have a flex that gives you your live, neutral, and earth, so your power. And then your 5-core, you will bring that in and you will take that to the wiring center where the motorized valves are, and you will make it off in there. But like I say, keep an eye out on the YouTube channel because there is a video, quite an in-depth video coming up on that. And similarly, if you're a 9 Degree Network member, have a look on the know-how section on some training, because we've got some installation and fault finding there. So if you need any more help on that, you can certainly have a look at it there. Right, let me have a look and see if there's any more questions. There's another question coming. This is actually one that came in off the promo video. This is about the 𝗲𝘀𝗀𝗀𝗀𝗀 underfloor heating controller. So let me bring you top down again so you can see what's going on. So we'll always get a lot of questions on this. So it's worth me just taking you through exactly what's going on with the 𝗲𝘀𝗀𝗀𝗀𝗀 underfloor heating controller. Let me get myself a little pointer here so you can see what I'm going on about. So 𝗲𝘀𝗀𝗀𝗀𝗀 underfloor heating controller, just to give you the outline, each one of these controls up to 6 separate zones of underfloor heating. So each one of these zones, or as many of these zones as you want to use, you would assign a 𝗲𝘀𝗀𝗀𝗀𝗀 room thermostat, and then within those 6 zones you can have a maximum of 14 thermal actuators. So this is a solution for multi-loop wet underfloor heating. Now, the reason you might get multi-loop is because in the same way that with your radiators, you want to try and balance the system. You want to make sure that you are able to deliver enough energy into the loop. So, and you do that by determining a delta T across the flow and return. That's why you would have multi-loop. If your loop gets too big, you'll have too great a delta T and you get too much losses. So when you're designing your underfloor heating, that will be factored in. So it may be that you've got one airspace that needs to be controlled by one room thermostat, but that's actually broken down into multiple loops that actually leave the manifold. So this is what caters for that. So if we start over here, let's start from, we'll go the opposite way, because this is sort of how I would approach wiring one of these. I start over here. So this is your mains in. So you bring, this is a class 2 product. You don't need an earth, even though there are earth terminals here, but these are earth terminals to maintain earth continuity for your pump. So these aren't actually connected to the chassis of this because it's all plastic. It does sit on a DIN rail and it has an externally mounted antenna, but you don't need to bring an earth into it to actually earth the control, but you absolutely do for your pump, because it's very rare, if ever, that you get a pump that isn't class 1, as in requires an earth, got some sort of metal casing or chassis. So normally when I'm wiring these, bring the live supply in here. So this is what's actually going to run the unit. And then these next terminals, you can see if I just take that in as tight as you can, and you can see that we've got the little wiring diagram on there, but you can see N3 and L3 they're just linked directly to the main incoming live. So that's really just giving you two terminals, which when this goes live, so by livening up this, you'll actually run the control, but this gives you capability to move live or neutral within the control. And the reason you might want to do that is because these terminals here, B1 and B2, this is an interlock. So in the same way that in a motorized valve, you've got a switch that when the valve is in the open position, the switch is made. This is exactly the same. When there's a call for heat on any one of the zones, the little switch inside there, so B1 is linked to B2 via a switch, which you can just see on the lasering there. But you can see it's volt free. So unless you bring voltage onto B1, you're not going to get anything out on B2. Where are you going to get the voltage from? Well, you're going to link from L3 across onto B1, and then B2 will give you a live signal. That's assuming that you want a mains signal. If you wanted a 24-volt signal, you would bring a separate wire in with 24 volts onto B1, and then B2 would go off and do whatever it's going to do. But generally speaking, B2, which is the output from your interlock, that's going to be driving the brown wire on a 2-port motorized valve. So you'll have a motorized valve that is feeding your manifold. The brown wire connects to B2. When there's a call for heat on one of these thermostats, B2 goes live. Consequently, your motorized valve opens, and then your orange wire on your valve, which will be wired up to all the other oranges on all the other valves that you've got in the system, will go out and fire the boiler. So as well as permitting flow into the manifold, it also sends the signal to fire up the boiler. So we then come on to our pump connections here, and this is where people get lost a little bit, because the pump connection actually requires you to bring a pump supply in. Now, this is done because we don't know the size of your pump, and also it's so that because there's no earthing requirement for the whole of this control, this is where you would need to bring a supply in that's got an earth on it. So N2 and L2 and the earth, this is where you would connect the tail of your pump. So that's going to be going out to your pump. And then, but in order for your pump to work, you need to bring a live in and a live and a neutral in, which is your N1 and L1. You need to bring a supply in along with the earth. So if I zoom in there, you can see that the little wiring diagram for the earth terminal, those two terminals are just linked together. So again, it doesn't really matter which way around you bring them, but N1, L1 will be a live supply that you bring in. So you will be actually bringing in a physical cable, connecting it to N1 and L1, and then N2 and L2, these ones here, this is going to be the output to your tail of your pump. If all you do is connect up those and you don't bring anything on there, your pump's not going to work. Now, this does have pump overrun. I think it runs on for about 2 minutes after the last call for heat, just to evacuate heat out of the manifold. And then we come on to our banks of thermal actuators. So, like I said, it's 6 zones, but it's spread over 14 thermal actuators. You don't have to use 14. You don't have to max out all of your banks here. So, if on number 1 you've only got, say, 1 or 2 thermal actuators, you would just wire them up. And the way it goes is the first terminal is the neutral, followed by the live. So it's neutral, live, neutral, live, neutral, live, neutral, live. That would be 4 thermal actuators. But like I say, you don't have to max them all out. If you just put one between 11 and 12, or say 14 and 15, that would do you absolutely fine. This here gets a lot of questions about that. This here is a changeover contact that allows the system to be thrown into cooling mode. Now, we don't really use this very much in the UK, normally because we don't really have the right radiators, or what would be more accurately termed emitters, if you're talking about cooling. So it is possible to cool by circulating cold water around a property, but you need to have the appropriate emitters in the room, because otherwise you're just going to have a condensation problem. You can't just send cold water around a typical radiator circuit. But because this is, the whole of WISER is starting to align itself with heat pumps and new heating technologies, we've got this contact in here that if you did want to if you did want to cool, so if you wanted your underfloor to be able to circulate cold water as well as hot, you would put a main supply across that, neutral and live across those two terminals, and then it will throw the whole system into cooling mode, which essentially just flips the logic. So whereas now a ambient temperature or a set point which is above ambient temperature would be a call for heat, a set point below ambient temperature would be a call for cool when those two terminals are made live. So that would normally be connected from a heat pump or something that's got a refrigeration cycle in it, which can be operated in reverse so that you're getting cooling rather than heating. And then the final bank here are for sensors. So the first one on the left, this is a floor sensor. So if you've got sensitive floor coverings, you can use our floor sensor, and then you can just put a limit on there to make sure that it doesn't go above or below a certain temperature. And then the D1 and D2, this is for a dew sensor. So really only applicable if you're using it in cooling mode. But essentially what it will do, it's a sensor that you strap onto the manifold, and as soon as it detects condensation, it will drop the system out of cooling mode. It will put it back into heating mode. Right, well, I think that's me done with the demos. Quick check-in to see if there are any more questions, and I'm not seeing anything. So that just leaves me to tell you about our YouTube channel. So anything that questions you might have about wiring up our systems or how things work, have a look at our YouTube channel, Drayton Heating. Lots of content on there. It's growing every day, so there's always new stuff. So make sure you get on there and subscribe. And if you hit the bell icon, you'll be able to you'll get notified when we release new content. So it's this is our trade channel. We do also have Drayton Home, which is more focused on consumer wiser. But if you want the detail on stuff, and this live stream will find its way onto our YouTube channel. And again, any video that you watch, if you've got a question, they're always monitored. So stick a question in the comments, and we'll do our best to come back to you. And anything you see will drive new content. So if there's a question that keeps on being asked, that will probably find its way into being a video or turned into a live stream. If you need any support on wiring, remember that we've got the Drayton website there, so draytoncontrols.co.uk. If you head over to the installers tab and then pick troubleshooting and resources, we've got all of our wiring diagrams there, which essentially look like this. So you just pick the one that is applicable to your system. So we talked a little bit there about BiFlow and twin zone. So BiFlow is what we would call a Y-plan system. You can see there's just the one mid-position valve there, and then twin zone is the Drayton terminology for an S-plan system, where you've got two port valves. Well, I don't see any more questions, so thanks for joining me tonight, guys. Keep an eye out on the channel, on the group, the Drayton community, for any up-and-coming events. I think Claire's probably going to be doing some more expert panels in the near future, so they're always good, to see what's going on in the industry. And also keep an eye out for my next session, which will be about in a month's time. If there's anything in the meantime that you want to see me cover, just stick it in the comments or comment on a YouTube video, and I'll do my best to make something happen. Thanks for joining me, guys. I'll catch you on the next one.